All right, we're going to talk about distance today. Remember, distance is the length between two objects or the space between them. Okay. So when we're talking about distance, the Pythagorean theorem is really what it's based off of. We have a distance formula, but again, we get that from Pythagorean theorem. And Pythagorean theorem says that for any right triangle, a squared plus b squared will equal c squared. So for any length that we have, right, we can find that length by finding a and b, squaring them both, and then taking the square root to find that value of c. So here's our first example. It says, what is the length? So length is what we're looking for. Our answer is going to look like either a radical, a whole number, or a decimal. Okay, so slope was a ratio, length is going to be a radical or a decimal. And we know here we've got our a and our b. So negative 3, 6, I'm going to plot those, and 2, negative 1. So we're looking for the distance between those points. So just like slope here, right, we're going to actually find how much we rose and how much we ran. Right, so we got 1, 2, 3, 4, 5, 6, 7 going down, and 1, 2, 3, 4, 5. Now with distance, negatives don't matter because when we square a negative, we still get a positive. Because technically I would have put a negative 7 there for slope. So I'm going to have 7 squared plus 5 squared equals our c squared. So we get 49 plus 25 equals c squared. And we're going to keep solving here for c. So when we add those two together, we're going to get 74. And then we're going to take the square root to get that value. And if we were simplifying the radical, we would create our birthday cake. But this is a number times 2 and 37, so like it doesn't break up any further than that. So C is going to be approximately 8.6, rounding to the nearest tenth. And this was by graphing. If they give it to you already on a graph, this is definitely the easiest method. The second one is by using a table, and it's going to function very similar to that slope table that you learned last year. So we're going to take both of our points, A and B, and plug them in to our chart. So we got negative 3, 6, 2, negative 1. And the key is that we're subtracting. So we're taking the difference between the 2 points. So we've got negative 3 minus 2, which gives us negative 5. And negative 6 minus negative 1, which gives us 7. Again, negatives don't really matter because when we square them, we get a positive. Now, if you type this into the calculator without the parentheses around the negative 5, it will give you a negative number. And that is because it is following orders of operations. Okay, so it's squaring the number and then timesing by a negative. You have to put it in parentheses. So we're going to get 25 plus 49 equals c squared. Notice this is the same example from above, but I wanted you to see that every method is going to give us the same answer. So here again, we're going to get 74 equals c squared. Take the square root. So c is approximately 8.6, rounded to the nearest tenth. And this is the chart method. The last one is the distance formula. If you are a formula person, this is the way to go. I like to remember it as a person with hair. So the hair is on top, okay? And then we've got our eyes, which are very sleepy, okay? And then we have our eyelashes and our nose, okay? And then we just fill that in with our X and our y's. Remember, it is a difference in between our x's, and then between our x and our y, it's a plus. So now we can just label our points, just like we did with slope, and we plug it into the formula. So we've got 2 minus a negative 2, and then squared plus negative 1 minus 6 squared. Now I'm going to retrace the things in black that are always going to be the same so that we know for sure these things are never going to change when we do the distance formula. It's just going to be those numbers that are only red that will change, okay? All right, so we're going to get our distance to be 2 minus, this should have been a negative 3. So that gives us plus 5. So we've got 5 squared plus negative 6. Negative 1 minus 6 gives us a negative 7 squared. Okay, so again, we're seeing that same pattern. So that's going to be 25 plus 49, which is ultimately 74. And then we take the square root of everything, right, because that's still on top of everything. So then we've got d equaling 8.6 again. Okay, so these are the 3 methods of solving for distance. The only way to get better at it is for solving it multiple times. Remember as well, you might hear distance as length. So length is another word that is telling you you are solving for distance. If you have any further questions, please see me in class.